So today we're going to look at how slope and similar triangles are related, because there is a way to show that triangles are similar if you look at the slope. So by that we're talking about right triangles. So we're just going to go ahead and jump right into our first example. So we're going to do a couple of triangles, and I am just sketching them because I don't have graph paper. So I am going to go just right over here to the right, and let's see, I'm going to say that's good enough, and go out this to the right. So just sketching this here. By the way, keep in mind that if at any time you get behind, you can pause the video so that you can catch up. And if you miss something, remember that you can always replay the video if there's something that you missed. Alright, so I'm going to just mark every two on the line, and then I'm going to try and do similar spacing out this way. Alright, so first thing you need to do is get your graph set up. So if you need to, you might need to pause the video. Alright, so for example 1, first thing we're going to do is sketch the triangle. So I'm going to say, draw the triangle ABC. So I'm going to say A is at 0, 2, B is at 0, 4, and C is at 3, 4. So first thing we need to do is plot this on the graph. So 0, 2 is right here. So here's our A. B is at 0, 4, which is right there. And C is 3, 4, which is right over here. So this is our triangle. So, and again, if I'm going too fast and you need to pause the video, then please do. Alright, so remember that we know that the slope of this piece right here is 0 because it's horizontal. And we know that the slope of this piece right here is undefined because it's vertical. So what we want to do is to find the slope of this side right here. So we want to find the slope of side AC. That's what we are looking for. Alright, so in order to find the slope, remember all we need to do is count rise over run, or you could just subtract the points. That works as well. But for this problem, I'm just going to count, and I go up 2 and over 3. So if we think rise over run, then the slope of this side right here is AC is going to be 2/3. So I'm just doing rise over run. Alright, let's try this triangle. So here's your second triangle. So we're going to draw the triangle D, which we'll say is at 4, 6, E, which is at 4, 8, and F, which is at 8, 8. So again, we're going to sketch this triangle as well. So 4, 6, so that means right 4 and up 6, which I think should be right about there. So that's D. And then over 4 and up 8, I think I'm counting correctly, is right here. So that's E. And then over 8, so 5, 6, 7, 8, and then up 8 should be right about there. So there's point F. So here is the next triangle. Alright, so in order to show whether triangles are similar, we have to find the slope. And again, we're not looking for the slope of this piece because we know that this piece is undefined. And we know the slope of a horizontal piece is 0. So what we want to figure out is the slope of DF. So slope of DF. All right, so again, we can subtract the ordered pairs if you want to do it that way. I'm just going to count. So the rise is 2. So rise over. And the run looks like it went from 4 to 8, which would be 4. And then we can reduce that to 1/2. All right, so what that tells me is that these two triangles, although they look like they're about the same size, they're not. They are not similar triangles because the slope of this one was 2/3. The slope of this one is 1/2. All right, let's throw one more triangle onto the picture here. So, triangle number 3. So, we're going to draw the triangle G, which is -2, 2. H, which is -2, 6. And I, which is at 4, 6. So, let's see, -2, 2 is going to be right out here. So here's our G. And then -2, 6 is our H. And then over 4 and up 6, which lands right here, is going to be our I. So here is our triangle for this. Ooh, yikes, that was terrible. Yikes, pretend that's straight. Gee whiz, that was awful. Good grief. Okay. All right, now, we can definitely tell that this triangle is bigger than the other two, but it could be similar in size and just a dilation, which is what we did earlier in the year back in Unit 1. So the way we need to figure this out is by finding the slope. We don't know, or we don't need, sorry, the slope of this one because we know that one is undefined. We know the slope of this one is 0. So what we want to find is the slope of GI. So the slope of GI is what we're looking for. So again, you can subtract the ordered pairs if you want. I'm just going to count though. So I went a rise of 4. So rise over the run. And for the run, I'm going from -2, so there's 2 spaces there, and 4 spaces there, so that's going to be a total of 6. And then we can reduce that to be 2/3. So the slope of this pink triangle is 2/3. So what that tells me now is that triangle 1 and triangle 2 are similar because the slope of side C is the same. So, let's see, how can we write that in here? Well, I guess I'll just go down here and here. So, let's say that those are similar triangles because the slope of side C is the same. So remember, we're talking about right triangles here. And then we're comparing the slopes of the hypotenuse, which is side C. And we know that those slopes are the same, which then tells us that those two triangles are similar. All right, so moving on to the other part in this is if you are asked to just find the slope of something. So let's just pretend that you have a slinky. So this is going to be example 2 here. So let's say that you have a slinky and you're going to stack it on a bunch of boxes. So you have this slinky and it is going to go down a board that you lean against these 4 boxes here. So, you know how a slinky works. It goes down, and then it goes down, and down, and then down. And just to make it look like a slinky, we can make it look like it's the little coiled stuff. So, the question is, what is the slope that the slinky is going to be moving. So we are asked to find the slope of the slinky. All right, so let's say that you have a stack of boxes that are 3 feet tall, and let's say the board that you are using is 5 feet long. So if we want to find the slope of this, we want to do the rise over run. So the slinky is moving down, so we need to go down and over. So we can see that the slinky is going to go down 3 feet. Let me do that in another color. So the slinky is going to go down 3 feet. What we don't know is how far over the slinky is going to go. However, remember that this makes a right triangle right here, and we learned in Unit 3 about the Pythagorean theorem. So we're going to use the Pythagorean theorem to figure out this missing side. So hopefully you remember a squared plus b squared equals c squared. So a squared, I'll just say, is 3. B squared, we don't know, but we know that the c is 5. So that would give us 9 plus b squared equals 25. So subtract 9 from both sides. So b squared equals 16, which then tells us that the side b is going to be 4 feet long. So we use Pythagorean theorem to find that this side is equal to 4 feet. So now we're asked to find the slope of the slinky. So again, the slinky's movement is down. So we are going down 3. So whenever we go down, it's negative. And we're going to go to the right 4. So that tells us that the slope of the slinky is negative 3/4. So main point here is that you're going to be dealing with right triangles, and in order for triangles to be similar, they have to have the same slope on their hypotenuse. So we don't worry about the slope of a horizontal or vertical line because we know those slopes. What we're trying to figure out is the slope of the diagonal line. All right, if you need to replay the video or stop and go back or even pause, remember that you have that ability with the videos, and good luck on your assignment.